All right, so we've looked through linear equations and done some applications of those. So we're going to the next level. Today we're going to look at quadratic equations. This is a pretty long lesson, so we might end up splitting it in 2 days, but I'm doing the whole video all together in one shot here today. All right, so how do we solve quadratics? Well, first of all, you got to know when you're looking at a quadratic. And you know that you have a quadratic in front of you because you have your highest degree is an x squared term. If you have that, then you've got a quadratic on your hands. All right, now we have lots of ways that we can solve these, and you've learned some of these ways, but each one kind of has their right time to use that particular strategy. So the first method typically is just going to be to look to factor. That's a very, very common way. And so you're going to use this option if the function or the equation is factorable. Can you factor it? Do you know how to factor it? Hopefully that answer is yes a lot of the time. Okay, so that's the first option. So if that, and another one that's probably equally as easy is using your square root property. And what you would do on the square root property is you end up taking the square root of both sides. Now, you're only going to do that if your squared term is isolated. And we'll look at a couple different scenarios on that. All right, another option that we use is to complete the square on it. And completing the square has a few purposes beyond just solving quadratics. So we're gonna use it to solve quadratics, but we'll use it again later in the semester as well. And next one, if completing the square maybe can get ugly sometimes, one other option that you're probably familiar with is using the quadratic formula. And you're going to use this if the other options are not really available or just aren't very nice. And then the last option would be even that. Maybe it's really, really messy or something, and you're just going to graph it. If you look at the graph, you're looking for the x-intercepts because the x-intercepts happen when y is equal to 0. And so typically when you're solving, you sort of make the y equal 0. All right, we're going to go through each type. All right, so this one is going to be solved by factoring. That's our first option. Whoops. So hopefully you can go, I'm just going to kind of go through these. If you feel like you're pretty good at factoring, you probably ought to just like maybe let me do one and then just shut the video off and go do it yourself and practice that. So ultimately, what's different here is from what we've been doing is that it now actually equals something. You have an equal sign, and you'll always want it to equal 0. So if it doesn't equal 0, then we have to do something to make it equal 0 first. Once you have it equal to 0, then you're just going to factor this. And the whole idea here is, and I'm just going to do a side note, you don't need to write this, but if you think about this, if you had two numbers, I'm just going to call them A and B, and you multiply them and say that it equals 0, you know that either A is 0 or B is 0. It's got to be the case. So that's what's going on here. When you factor this, you have two things that are multiplied together and they equal 0. In this case, I've got factors of 10 that have a sum of 7 or negative 7. So factors of 10 are going to be 5 and 2. It's a positive 10, so my signs are the same. They're both going to be minuses. Now, like I was saying before, I'm taking this times this and saying it equals 0. So that means either this is 0 or this is 0, or maybe both. So we would set those each equal to 0 and get your two solutions. X is 2 or 5. Those are the two values you could plug into the original equation and make that work out. All right, another factoring one. Feel free to like turn me off and just go do your own thing here for the next 3 problems. All right, this one looks like a factoring with a GCF, so I'm going to pull a 2x out of this. Remember, when you pull out the entire thing, you've got to leave a 1 in its place so that you would be able to redistribute and get back to where you started. All right, what's weird about this is now the multiplication is kind of happening right here. So either 2x equals 0 or 2x minus 1 equals 0. On this one, this is just a nice one. It just ends up being a 0. Over here, you can do steps, or if you can do it in your head, that's great too. Just add the 1 and then divide by the 2. So that's going to end up getting me a 1/2 for my solution on that. All right, next one, I had talked about how it's supposed to equal 0 first. This one does not. So all you're going to do is just bring everything over to the same side. And then you're going to factor it. So factors of 2 are going to have to be 2 and 1. Factors of 4, you can do 2 and 2, or you can do 1 and 4. The thing is, though, is my signs are going to have to be different because it's a -4. And if my signs are different, then my outer and my inner have to subtract to 7. And the only way I can subtract to 7 is by getting a number bigger than 7 and then a number smaller. So what I'm going to do here is I feel like I'm going to have to go with the 4 here so that I can get that up to an 8. There's my 8x, and I'd go 4 and 1. 8x and 1x, that works. Now I do want a positive 7, so I'm going to make my 8 positive. All right, so now what I've got here are my two factors. I've got it factored. Now you can set it equal to 0. I have been showing you that step of setting it equal to 0, but I know you've done this solve by factoring several years now. So if you can just do that in your head, that's great. You don't have to show me that step. So on this first one, if that were set equal to 0, I'd add 1 and divide by 2. The second one, I would be subtracting 4. Those are my solutions. Last one, I made it a little bit harder. I think you're going to want to pull out a GCF on this. Let's pull out a 2x. Because I guess what I should comment here is that this is no longer a quadratic. It's actually a cubic because now your highest degree is a 3. And so we still actually can solve cubics by factoring 2 if it's the right type of cubic that we're able to factor. So then that gets me an x squared plus 6x minus 7. So now I'm looking for factors of 7. That will subtract to a 6. That's going to have to be a 7 and a 1. No options. I want the 7 to be positive. That's negative. All right, so I'm going to have 3 solutions since it's a cubic. If I set 2x equal to 0, then I'm just going to get 0. If I set 1, or if I set the next one, I'm going to get a 1. And the last one, I'm going to get a -7. And those are your solutions. All right, let's move on to the next type. This one we're going to solve by using our square root property. And what we said that means is that you want that square term to be isolated, and then you're just going to square root both sides. So looking at this first one, I see that there's an x squared. And I should comment that we're doing the version where there is no b term and there's no linear term. That bx that's usually in the middle is not there. So you can say I only have an x squared and a constant. Only an x squared and a constant. All right, so what you want to do is you want to isolate that x squared. I'm going to add 15 to the other side and divide by 3. And then, if you'll recall, you're going to square root both sides here. And when you square root both sides, don't forget that there's a plus or minus that goes there, because my x could have been positive or negative, and then when I squared it, I could have gotten a 5. So your answer on this one is a plus or minus square root of 5. You should still be getting 2 answers all the time because it's an x squared. All right, here's my next one. I'm going to subtract the 25. I'm going to divide by 9 to isolate. 25/9 is not going to reduce, so I just jump right in and square root both sides. And so my x is equal to, now I made this one come out pretty nice. It's going to just be a nice 5/9, but notice that it is negative. That's why we talked about complex numbers yesterday, because this is actually going to be, yes, it's going to reduce to a 5/3, but it's a 5/3 I because it's negative inside there. And remember, every time you do your square root of both sides, you got to do your plus or minus in the front. Still going to have two answers. All right, so then the next scenario is when you have like a whole quantity that's squared. Then you're just trying to isolate that quantity. And you can just jump right in and square root both sides. So then I have an x minus 2 equals a plus or a minus square root of 6. And then you add the 2 over, and this is two answers, 2 plus root 6 and 2 minus root 6. Those are my two answers. I'm going to leave these exact. I don't need to go decimal on those. All right, this next one is pretty similar. I should have probably done something fancier with it, because if you have like a number in front, let's say there was a 4, then you would divide by 4. Let's say you were adding inside there, then you'd move that. You still got to get that quantity isolated before you take the square root of both sides. All right, so in this case, I am just going to square root both sides. I got 2x plus 3 is equal to a plus or minus 1. Subtract the 3. Now this is a little bit different. When I subtract the 3, now this came out nice. So what I have to do is I have to actually evaluate what that would be. If it was a 1, a positive 1, and I subtracted 3, then I'd get a negative 2. But if it was a negative 1 and I subtracted 3, I would have gotten negative 4. So I would have a second scenario over here where 2x equaled negative 4. Those are my two options. All right, now you divide by the 2 on both sides. We get negative 1 and negative 2 as our two solutions. All right, this is going to be solving by completing the square. That's how I abbreviate completing the square. Okay, so looking at this first one, we are not doing the factoring thing, so I don't care that it doesn't equal 0. What my goal on this one is to create what we call a perfect square trinomial. A perfect square trinomial will factor to just a binomial squared, which is what we had on that previous slide, where binomials squared. So that's where I'm headed. Now there's a customized way that you can do this, and it works every time. And what your goal is you're going to go ahead and write the k squared that I have here. Now, this leading coefficient does have to be a 1. So I'm starting with an easier one where your leading coefficient is 1. And then I'm going to do a plus 16k. And then a plus. And now what I'm going to do is I'm going to put in a blank right here. Equals, and I'm going to move the 57 to the other side. So I am going to subtract 57. That would take me to a negative 63. Now, what I'm going to do is pick a customized perfect number to put in right here so that this will become a trinomial, a perfect square trinomial. To find that number, what you always do is you take this coefficient here and you take half of it, so that'd be 8, and then you square it, so that'd be 64. Half of it squared, then you put it right there. So that would be 64 I'm going to put right here. But I do have to consider for a second here that, I can't just randomly put a plus 64 on this side of the equation and think it's still going to be equal. It's not. So I have to balance that. So whatever I put in this blank here, I always have to do the same thing on the other side. So I'm going to add 64 on this side also. And that's going to come out real nice for me. That's going to end up just being a 1. Over here, this is going to factor, like we said, it's going to be a factor as a binomial squared. Ultimately, I'm just squaring root in my first term, square root in my last term. I'm going to put a plus sign in there because I can see that my signs would have both been pluses. Now I'm looking at a situation that looks like the previous slide. I'm ready to do that square roots. So we're going to square root, which is going to get us a k plus 8 equals plus or minus 1. and then just subtract the 8. Now you have a couple options here. If the 1 was positive and you subtracted 8, you would have gotten a negative 7. But if the 1 was negative and you subtracted 8, you'd end up with a negative 9. And so those are your two solutions for this problem. Let's go over here on the right. Let's do the same thing, a little bit different because I got a little bit more going on the other side. But more importantly, my bigger concern is this 2 that is in front of the x squared. This needs to be a 1 to be able to complete the square. So let's do some rearranging. First thing I want to do is I want to get the 3 on the other side. So I'm going to subtract the 3. But as I'm moving the 3 here, notice that I don't want a variable over here. So I'm going to bring this x over to there. So then I'm going to end up with a 2x squared. When I subtract the x, it'll be a minus 2x equals, and then that x is gone, and I'm going to subtract my 3, so it's a 6 over there. Now I have to work on that a value. I got to get that out of there. So if I'm lucky, I'm going to be able to just factor it out, and I'm lucky on this example. If it's not going to factor out, it doesn't matter. You still have to factor it out. If this was a 3, well, that wouldn't divide by 3 nice. I still would factor it out. It's just going to turn that into a fraction. And sometimes that's what happens. But I'm going to pull that 2 out, and I'm only doing this on the left side of the equation. Don't do anything with that 6 over there. So I'm going to have an x squared and then a minus x. And now that this first term is now a 1, I'm going to go ahead and add my blank in here. Equals 6. All right, now you go, here's the pattern. You always go to this middle term right here, and you look at the coefficient, happens to be a negative 1. You take half of that, half of negative 1, that's negative 1/2, and square it. So I have to square that. That's going to end up being a 1/4. But when I put the 1/4 there, again, I actually added it to the left side. I got to keep it balanced. I got to do it on the right. But be careful, because when I put a 1/4 in the blank, that 1/4 is going to get multiplied by the 2. So I didn't really put a 1/4 on the left side. I put a 1/4 times 2, which is a 1/2. So what that means is that I put a 1/2 on the left side. I'm going to add a 1/2 on the right side. All right, now I'm going to get this 2 here. This is going to factor to some binomial squared, and we customized it to do that. It's going to be an x. Because this is a plus sign, their signs would be the same, which is going to happen every single time. They're both going to be whatever that one is. So it's x minus, and then ultimately I'm just square rooting. The square root of 1/4 is a 1/2. So it's whatever you squared to put in there, that's what goes in that blank. Equals, and then this is a little weird over here, this 6 plus a half. We don't really do much with mixed fractions, so to do computation. So we're going to have to change that, and we're going to have to write the 6 as a 12 halves plus 1/2. Okay, oops, sorry, I don't know why I wrote 12 twelfths. Let me erase that. 12 halves plus, I wrote that totally wrong, didn't I? Let's just start over, sorry. Let's make sure everybody's clear on this. So 12 halves is what 6 is when you convert it to a fraction. And I couldn't erase that, sorry. So it's just going to be a plus a 1/2. So ultimately, that's going to be a 13 halves. On this side, I'm going to want to get rid of that 2. So I'm going to divide by 2. Dividing by 2 is the same as multiplying. So I could do the same thing on the right side, divide by 2. But since it's already a fraction, instead of dividing by 2, I'm going to multiply by 1/2. Now, okay, let's see if we can get something cleaned up here. We got an x minus 1/2 squared. I'll go ahead and write that. But I'm ready for the next step. I'm going to go ahead and multiply those together. That's a 13/4, multiplying straight across. This is x minus 1/2 squared. I'm now ready to square root both sides. It's going to equal a plus or minus. All right, this ain't very pretty. When you square root a fraction, you ultimately just square root the numerator, so that's square root of 13, and you square root the denominator, which happens to come out nice, so I'm not going to have it in a radical anymore. It's just going to be a plus or minus root 13 over 2. Okay, so then my last step is to add the 1/2, and then I'm done. So it's going to look like, you can write it as a 1/2 plus or minus root 13 over 2. But since they have a common denominator, you can just merge that into one big fraction if you wanted. Don't forget your plus or minus to designate your two different answers, though. And then, again, we're leaving these exact, no decimals on this. All right, so that's a little bit more challenging one, no doubt. So let's practice that one more time. My goal here is that you maybe try this one on your own. So you could pause the video. I gave you this A value that you're going to have to deal with. If you feel confident, then why don't you go ahead and give this one a shot? Maybe give it a shot anyway, even if you're not confident. See if you can get into it a little bit. Turn off the video, come back when you're ready. All right, so our first step on this would have been to do 4n squared minus 8n, add the 31 to the other side. But I can't really put in my plus blank until I get that leading coefficient out of there. So I'm going to divide everything on the left by 4. So it's going to be this, just factoring it out of there. Now I'm ready to do the plus something equals 35. Now let's go ahead and complete the square on it. I look at this b term, it's a -2. I take half of that, -1, and I square it. Now, because you're squaring it, that's why this is always, always, always a plus sign. So -2, half of that is -1, squared, +1. Okay, this might be pretty all right. Now, remember when I put that 1 there, though, that 1 is getting multiplied by my 4. So this is not really a 1, this is really a 4 when I put that 1 there. So I'm going to add 4 to the other side. Then this quantity is going to factor to an n minus 1 squared. Now I start peeling away, get that binomial isolated. So I'm going to divide both sides by 4. And then you're ready to square root both sides. So n minus 1 is equal to a plus or minus. Looks like we got the same deal as last time, where the 4 is going to square root nicely, but the square root of 39 is not. Sometimes if they both reduce a little bit or something, you might be able to do some reducing. My last step, go ahead and add the 1 over. So I'm going to write it as a 1 plus or minus square root of 39 over 2. All right, what do you think? Did you get through it on your own? All right, so here I have just a little to-do list. We did 3 examples of that, but if you get home and you forget use the to-do list to help you through it. All right, so now we're going to move on to using a fourth method. Now we're going to use the quadratic formula. Now, actually, the quadratic formula is not some magical formula. Actually, the quadratic formula comes from taking a quadratic that looks like this. We take all the numbers out of it and we just put variables to represent those coefficients, and we complete the square on this thing. And we just pretend those variables are numbers and do all the operations. If you complete the square on it, you end up with this right here for an answer. And that's where the quadratic formula comes from. What's nice about it, it's sort of just cut and dried. If you could identify your A, your B, and your C, you just insert them in the appropriate places, and you'll get your answer a lot faster than completing the square. So let's go ahead and try this first one. The key thing here is that before you get started, it's got to equal 0. So my first step would be to go ahead and subtract that 4 back over here. And then you're going to identify what is the a. Well, that's the coefficient on your x squared. Your b is your coefficient on your x. And your c is your constant. And now you're going to go through and use your quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And now your next job is to simplify all this stuff inside of the radical. All that inside there is called the discriminant. And I usually just multiply the last three numbers, so that's going to end up being a negative 32, but I'm subtracting negative 32. That's going to turn that into a 33. So square root of 33 all over 4, and we're done. We're going to leave it exact. If I wanted a decimal approximation, I just have to run that through my calculator with a plus sign and then run it through with a minus sign. Remember, you're always supposed to have two answers because it's a quadratic. All right, see if you can do the quadratic formula on this next one. Pause the video. All right, I gave you a sneaky one. This one, well, I say sneaky, it was kind of good because your discriminant, that all that stuff that's underneath the radical there, that all ended up just becoming 0, which makes the math pretty easy on it. So if you're working it through, if that becomes a 0 right here, then all you have is a -6 plus or minus 0. That's just -6 divided by the 2. You only have one answer. Now, I just got done saying you have to have two answers, but here you only have one. Well, I hope you just jumped in and did it because I was trying to not let you notice that this would have been a beautiful factoring problem. That just factors as an x plus 3, x plus 3. And if you set those each equal to 0, well, you're going to get the same thing both times. So you get x equals -3. And so that's the only reason that you would only have one answer instead of two answers, is because you ended up with the same answer actually occurring twice. So you can have just one answer. Special situation. So let's take a look at the different ways, different things that can happen with your quadratic formula. So this situation right here could happen. If you end up with a 0 underneath there, then, and again, that's called the discriminant. If that is a 0, if your discriminant is 0, you're going to end up with the same thing happening where that all goes away, and you're only going to get one solution. So one thing that might happen is that you only get one solution. And it's actually typically a really nice solution because the 3 and the 6 that are left come out nice. So typically you're going to get one nice rational solution. All right, next best thing I suppose that could happen could be that you end up with that discriminant being a perfect square. That's kind of nice because then when you do the square root of that, you'd get a 5. Okay, so now you don't have a radical in your answer anymore. You'd still have two answers out of it because you'd have to add and you have to subtract. So you're going to have 2, and it will come out nice. The radical will be gone, so you'll have 2 rational solutions. Okay, we're gradually going to get worse here. Next worst scenario, I guess, would be, well, you end up with a negative under there. I don't know if this is the terrible, but the problem is if you end up with a negative discriminant, this is going to be imaginary. So you might end up, there's still a plus or minus, so you'll still have 2 of them, but they will end up imaginary answers. And we'll talk about what that means in a minute. And then I suppose the other scenario would be that it's not negative, but it's irrational. And so you're not going to be able to do anything with it, so your answer will end up irrational instead of rational. Now you might notice on this 8, this would reduce. Just so if this discriminant is a reducible radical, go ahead and reduce it. But an 11 wouldn't reduce. And so all you're going to end up with is 2 irrational solutions. All right, so let's kind of summarize that. I've got this nice flowchart looking thing, and it talks about, okay, so really when you're talking about the discriminant, I'm really just talking about the b squared minus 4ac. I don't even put the radical on it. It's just the b squared minus 4ac. What is that number? All right, we just kind of wrote it. I'm going to kind of write it again so it's on a clean sheet here when it shows you nicely. If the discriminant is equal to 0, you're going to have one rational, we said. It comes out nice. If it was negative, you were going to have 2 imaginary. Those are kind of the ones that jump out at me. Now, if it's positive, it might come out really nice as a perfect square, which means your radical will go away. Or it doesn't come out as a perfect square, so you'll have 2 irrational. So you kind of have an idea of what's going to happen before you ever jump into it. All right, we're getting ready for our 5th and final method of solving a quadratic, and it's going to be through graphing. So I want to kind of talk about, before I go to that, what these answers would look like on a graph. Now, a quadratic is going to graph like a parabola. And when we set these equations equal to 0, what we're really doing is we're making our y equal 0 on that parabola. Because normally you would have something like this. You don't need to write this, but normally we'd see something like a y equals ax squared plus bx plus c. It looks like that. But now we're setting it equal to 0, so we're making the y be 0. And thinking on a graph, when is the y value 0? Well, that's going to happen anytime you are on your x-axis. So to solve this graphically is to find out where your parabola would touch your x-axis. All right, so let's look at these graphs. If I only had one rational, 0, that means it only would touch the x-axis one time, like right there. If I have 2, whether they're rational, irrational, it'll touch twice. If it's rational, it's going to hit at nice integers. If it's irrational, it won't. And then you got these 2 imaginary, which means it's not going to touch the x-axis at all. So what we're trying to do here is draw a parabola that will touch the x-axis like we're saying. So in this scenario, your parabola would come down and just touch right there at that one spot, and that's the only intersection it would have. On the other 2 scenarios, it's going to come down and back up. It's going to hit twice. The imaginary, meaning it can't touch, means it's going to come down and back up and never touch that x-axis. Now, I want you to hold on to that thought because I do want to practice a little bit with this discriminant, and then we're going to jump into that graphing method and use kind of what I just did there to come up with our answers. So just a little bit of practice with discriminant. All right, so all I really care about here, I don't want to know what the answer is. I just want to know what kind of answers I would get. So what I'm doing is I'm taking and figuring out my discriminant. Notice in my first one that it's already set equal to 0. So all I'm doing is figuring out what is b squared minus 4ac going to get me. All right, so b squared would be 9 minus 4 times negative 2 times 5. All right, so that looks like that would be negative 40. 9 minus negative 40. Okay, that's a 49. And 49 is a perfect square. So what's going to happen is that it's going to square root really nicely. I'm still going to have 2 answers, and they're going to be rational because the square root will go away. So that's what you would write. You're going to say you're going to have 2 rational, and they'd be real, not imaginary. Okay, next one is not equal to 0, so get it set equal to 0. I'm going to let you do this one on your own. Pause the video, go find out what the solutions would look like. All right, so I ended up with a negative 46. And honestly, I knew pretty quickly, I knew way back here, I'm going to end up with 2 imaginary. If all they're looking for is that information, don't feel like you have to go find it exact. If you can tell right here at that stage it's going to be imaginary, then make note of it. Okay, I have one other scenario that I think is kind of a cool option for us now that we know the quadratic formula, is how do we solve a cubic? Now, This is really, we know this. We know how to factor this. You would just take x cubed and you would do that crummy sops or cube root sops or whichever way you've learned it. All right, so let's factor this because on this one I'm actually trying to solve it. So we have an x plus 2. Remember, you just cube root the two numbers, keep the same sign. Now I'm ready for the sops. You square the first term, that's the s. Do the opposite sign. Find the product, plus, and then you square the last one. Now the way this sets up, that trinomial will never factor. But if I set this equal to 0, I can get the x plus 2. I know that x will equal a negative 2. So I've got myself one x-intercept right there. That's one of my solutions. But the next one is not going to factor. So what I'm going to do on that is I'm going to do the quadratic formula. So I'm going to come over here on the side and do that so I don't run out of room. So for some extra zeros or extra x-intercepts, x equals negative b plus or minus square root b squared minus 4ac all over 2. All right, now I am looking for the solutions. I don't know how quickly you notice that, oh, I'm going to end up right here subtracting 16. That is not going to play out nice. 4 minus 16, that's a negative 12. Right now in my head, I know I've got some imaginary solutions. I'm going to go ahead and write it like this for now. I want to know more than just that there's two imaginary. I actually want to know what they are exactly. So I'm going to reduce my square root of 12, my square root of negative 12, and that's going to become 2i root 3. But one of the things I want you to notice here is that on the quadratic formula, you oftentimes can reduce with this 2a that you have on the bottom. But you have to remember that all of this is dividing by 2. So don't just look here and try to slash. Remember when we did rationals, the plus or minus ties this all together. You can't just pick at it. So everything would have to divide by 2, which it does. So I always look at these three numbers and I say what goes into all of them, and then I'll divide by that. So final answer on this actually is going to become 1. Don't just cross off the 2 and leave nothing. You got to have that placeholder, plus or minus I root 3. And the 2 on the denominator, no need to write it as a fraction over 1. It would just go away. Now, so my solutions on this, overall final answer, x equals negative 2 and 1 plus or minus I root 3. Woohoo, we made it to the end. Well, we're not really at the end yet. We're on the fifth method, which is to solve by graphing. And by that, I mean using your graphing calculator. And remember, what you're looking for are the x-intercepts or the zeros of the function. Okay, so kind of to show me some work on this, I'd want to see what the graph looks like. So you would sketch me just a little light graph so I know some idea of what you are looking for. All right, if you don't have your graphing calculator out, grab it. I'm going to try to show you with some screenshots what all you need to press, what buttons you need to press to get this to graph and to find where those x-intercepts are. All right, so the first thing you want to do is you want to go right into your y equals right here, and you're going to type in the equation they gave you. And this was an unfortunate screenshot because this cursor was blinking, and when I did the screenshot, it blinked on. There's an x here. This is x squared plus 4x minus 7. All right, so you're going to type that in. Now, before you get crazy and just try to graph it, you know your window might be pretty messed up. So you pretty much probably on these problems will want to have just a standard 10 by 10 window. And I don't know if I've shown you this yet or not, but you could go to window and put in all the negative 10, positive 10 thing. But here's a quickie shortcut. If you just push zoom and go down to number 6, and I always just press 6. I don't go down, enter. I just hit 6. It immediately will take you to a zoom standard window, which is our standard 10 by 10 window. So that's a quickie way. Once you get your standard window, actually, I think if you hit that, it immediately graphs it also. Otherwise, go hit graph. And here's my parabola. It went a little bit low here, but I'm not too concerned about that because I know what I'm looking for are these x-intercepts. Looks like they didn't come out very nice. If they don't come out as nice rational numbers, it means this was not factorable. If they were integers, it means you could have factored it. So looking like this one was not factorable, which I can glance at it and tell. Okay, so now I got to find my answers. Means they probably were irrational, would have had a radical, but I'm going to just get them as an approximated decimal from my calculator. So to do that, you're going to hit second, trace. It will take you to this window here. And this is an important window. We use this menu of options all the time. So what we want right now are the zeros. Those are x-intercepts. So press 2. Now what will pop up is your parabola with your cursor somewhere in there. And then you got to read down here because these are kind of your instructions. It says left bound. Like, is this, so you're going to want to move your cursor so that it is left of the x-intercept that you want. So I conveniently am already left. So you go left, 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 left with your arrow right here, left, 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 until your cursor is left of the x-intercept you're searching for. And then you press enter. And then it's going to say right bound. And so then you're going to go right, 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 until your cursor is right of it and press enter. And you're going to get this screen. And what they're really doing here is they're saying, oh, you mean you want the x-intercept that falls between these two lines? And it's like, now it will make you, or it will let you make a guess. Here's the deal. If you get a little sloppy with your left and right bound, and you maybe have your left bound here and your right bound is way over here, well, you have two x-intercepts in that space. So your guess is them asking you to move your cursor close to the one you want. But here's the deal. If you're smart about it, don't do that. Make your intervals small, and then I just press enter. I don't even worry about where the cursor is. I know that it's in that space. So then immediately hit enter, and it comes up to this window here. And it puts your cursor on the x-intercept, and it tells you down here what it is. So we have an x-intercept at negative 5.32. And then you would start all over. You'd go back to your second trace and do it all over again. But this time you're going to be doing that with the other x-intercept. If you do that, you have a second answer of 1.32. So don't come out nice. They would have been radicals, but here's a nice decimal approximation for it. All right, we are done. You have 5 methods. Make sure that you're following directions of which method you're supposed to use so that you get practice with every one of them. All right, thanks for hanging with me. Bye.